Welcome to Talking Ketamine, episode 25.
Great to be back.
Today we're exploring something really fascinating.
Mm-hmm.
How ketamine might actually influence our fear memories.
Big topic.
Yeah, imagine being able to somehow lessen the grip of traumatic experiences. That's the potential we're looking at.
It's definitely exciting. And our discussion today, it's centered on a very recent comprehensive review.
Okay.
It's looking at the preclinical literature published just this year, 2025.
So brand new findings.
Pretty much. It's titled Effects of Ketamine on Fear Memory Extinction, a review of preclinical literature.
Right.
Published in Frontiers in Neuroscience. And the authors are Martin Bose, Rena Berman, Kenneth Radford, Luke R. Johnson, and Quang Choi.
Got it. So this isn't necessarily about immediate clinical use just yet.
Not directly, no,
Yeah.
but it gives us, incredible insights into the how.
The mechanisms.
Exactly. How ketamine might provide some of its most talked about benefits, especially for understanding things like post-traumatic stress disorder, PTSD.
Okay, so let's start unpacking this. Where do we begin?
Well, maybe first, let's just quickly make sure we're on the same page about PTSD itself.
Good idea.
So it's a psychiatric disorder, right, linked to experiencing or witnessing traumatic events.
Things like serious injury or sexual assault, combat.
Exactly. And the symptoms, they can be really intrusive. Things like unwanted memories popping up, flashbacks.
Yeah.
People might avoid places or situations that remind them of the trauma. There can be negative changes in mood, in thinking.
And that feeling of being constantly on edge.
That's right. Heightened arousal, reactivity. It's really debilitating.
And it's quite common, relatively speaking. It affects about, 7% of the U.S. population in their lifetime?
That's the figure, yeah. But it's also really important to remember not everyone who experiences trauma develops PTSD.
Right, only a subgroup, which itself is interesting why some people and not others.
Absolutely. That touches on resilience, vulnerability, complex factors.
Okay, so how is it typically treated now?
The current standards, well, psychotherapy is often considered first line.
Like exposure therapy.
Things like prolonged exposure, cognitive processing therapy, yes. And then pharmacotherapy, medication is often second line.
And for meds.
Only 2 SSRIs, sertraline and paroxetine, are actually FDA approved specifically for PTSD.
Just 2?
Just 2. And honestly, the response rates can be pretty poor for a lot of people. Plus, dropout rates from therapies can be high. Sometimes the therapy itself is very intense or symptoms are just too severe to engage fully.
Which clearly highlights the need for, better options.
Definitely. A real need for improved therapeutic strategies.
So how does this link to the concept in the paper's title, Fear Memory Extinction? What is that exactly?
Right. So fear memory extinction, it's a learning process. It's not about forgetting. That's key.
Okay.
It's the process where someone or, an animal in these preclinical studies learns that something they previously associated with danger is actually no longer harmful.
So it's learning safety. A new association overrides the old fear one.
Precisely. It's new learning.
Okay, that distinction's important.
Yeah.
So how do researchers actually, study this in the lab with animals? Make it concrete for us.
Yeah, it's quite a standard procedure, actually. Usually involves something called fear conditioning.
Okay.
So imagine a rodent, maybe a rat, in a neutral setting. Could be a specific cage, or they might hear a specific sound, like a tone. We call that the conditioned stimulus, or CS.
The neutral cue.
Exactly. Then, at the same time, they're exposed to something unpleasant, an aversive, unconditioned stimulus. Often it's a mild electric foot shock.
Okay, so the animal quickly learns tone equals shock coming. Or this cage means shock.
Exactly right. They form that association. So after this fear conditioning phase, if you just present the tone or put them back in that cage, just the CS, no shock, they'll show a fear response.
Like freezing.
Freezing is a very common measure, yes. It shows they've learned the fear.
Okay.
Now, for fear extinction, you repeatedly expose the animal to that CS.
Yeah.
The tone, the context, but without the shock, again and again.
So they learned the rule has changed.
Exactly. Over time, with these repeated safe exposures, the animal learns the CS is no longer predictive of danger. The fear behavior, the freezing, gradually decreases.
So it really is like learning to feel safe again in that specific situation. That makes a lot of sense. You can see the parallel to therapy.
You really can. And this is where ketamine comes in, according to this review.
Okay, how?
The review highlights that these sub-anesthetic doses of ketamine, the lower therapeutic type doses.
Not the surgical anesthesia doses.
Right. They work by inhibiting NMDA glutamate receptors, But crucially, they seem to preferentially inhibit these receptors on inhibitory neurons.
Wait, so inhibiting the inhibitors, inhibiting the brain's brakes.
That's the idea. So it's not just quieting things down.
No.
By taking the brakes off, you paradoxically get an increase in glutamate release overall.
Ah, okay. Glutamate being the main cook signal in the brain.
Precisely. It's the primary excitatory neurotransmitter. This glutamate surge then activates other receptors called AMPA receptors. And that boosts neuron excitability even more. But the cascade continues. This increased activity, particularly in learning and memory circuits, leads to more release of BDNF.
Brain-derived neurotrophic factor. That's the one people call brain fertilizer, right?
That's a great analogy for it, yeah. BDNF is critical for synaptic plasticity. It helps synthesize proteins that strengthen the connections, the synapses, between neurons.
Leading to LTP, long-term potentiation.
Exactly. LTP is the cellular basis for learning and memory. It's how the brain forms strong, lasting connections.
So putting it all together, it sounds like ketamine is almost creating a state where the brain is more receptive to making new connections, to learning new things, to basically rewiring itself.
That seems to be the core hypothesis, yes. Creating a window for enhanced plasticity and learning.
So given that mechanism, what did this review of those 15 preclinical studies actually find?
Okay, so they looked at these 15 articles, mostly using rats, all focused on how ketamine impacts this fear memory extinction process.
And was there a clear trend?
There was. The majority, about 2/3 of the studies they reviewed, showed that ketamine actually enhanced fear extinction.
Enhanced it, so it helped them overcome the fear faster or better?
Yes. The animals learned to reduce their fear responses more effectively when ketamine was administered in conjunction with the extinction training.
Wow.
And this wasn't just a fleeting thing. It was seen both within a single extinction session quicker learning and also across multiple sessions, suggesting a more durable effect.
That sounds really promising, but science is usually messy. Were there any studies that found something different? Maybe ketamine didn't help or even hurt?
That's a really important question. Because yes, the picture isn't perfectly uniform.
Okay.
A few studies actually reported that ketamine impaired fear extinction. Made it worse.
Impaired it. How could that happen?
Well, this negative effect seemed particularly linked to how the ketamine was given. It was most noted with intravenous or AFV infusion.
Ah, the delivery method matters.
It seems to. The hypothesis they discuss is that IV ketamine might, maybe because of faster absorption or higher peak levels, lead to a bigger release of noradrenaline.
Stress hormone.
Right. Specifically in the amygdala, that fear center we talked about.
So too much noradrenaline in the amygdala could actually stamp in the fear memory even stronger, counteracting the extinction.
That's the thinking. It really highlights how critical the dose, the route, and maybe even the timing could be.
Let's talk about timing. You mentioned timing being critical.
Absolutely crucial. There's this fascinating interplay between memory reconsolidation and extinction.
Reconsolidation. That's when a retrieved memory becomes fragile again for a short time.
Exactly. When you recall a strong memory, like a fear memory, it briefly enters this unstable state where it can actually be modified or updated before it gets stored again.
Like opening a computer file, you can edit it before you hit save again.
Perfect analogy. So if you trigger the recall of the fear memory, opening that window, and then you do the extinction training while the memory is in that malleable state,
you could potentially rewrite it as less fearful.
The evidence suggests exactly that. It can significantly enhance fear reduction and, really importantly, make that reduction more resistant to relapse later on.
So timing ketamine administration around that reconsolidation window could be key to maximizing its benefit with therapy.
That seems to be a very promising avenue for future research and clinical application, yes.
What about other factors? Did the review mention anything about, say, individual differences between the animals? Like sex differences?
It did, and that's another critical layer. They noted significant sex differences.
Oh.
Specifically, female rats seemed to clear the ketamine from their system more slowly.
Okay.
And the drug's effects lasted longer compared to males. This could mean females might have an enhanced behavioral sensitivity to ketamine.
So the same dose might have a stronger or longer effect in females.
Potentially, yes. It underscores that we can't assume a one-size-fits-all approach will work. Physiology matters.
Okay, this is all fascinating preclinical work. Let's bring it back to the human level. What does all this potentially mean for you, our listener, thinking about PTSD treatment?
Well, the strong suggestion from this body of evidence is that ketamine, when used carefully and strategically,
Right.
might be a really valuable tool to combine with existing effective psychotherapies, especially extinction-based ones like prolonged exposure, PE therapy.
PE therapy, which involves that gradual exposure to trauma reminders.
Exactly. Helping the person learn those cues are safe now.
So the idea is ketamine could make the brain more receptive to that safety learning during PE sessions.
That's the core hypothesis. It might accelerate the process, deepen the learning, maybe even make the therapy feel more manageable for people who find it very difficult.
Is anyone actually testing this combination?
Yes, absolutely. This isn't just theoretical anymore. The review mentions a major clinical trial that's currently underway.
Oh, really?
Yeah, a double-blind, randomized controlled trial with 100 veterans with PTSD. They're comparing IV ketamine versus an active placebo midazolam, which has sedative effects but not the same presumed mechanism,
Okay.
as an add-on, an adjunct to PE therapy.
How are they timing it?
In this specific trial, they're giving the ketamine or placebo infusion 1 day before the PE sessions.
Interesting, priming the brain beforehand.
That seems to be the rationale. They're
Right.
doing this for the first 3 weeks of therapy and then following up for 3 months to track PTSD symptoms.
That sounds like a really important study. It could give us real answers about this synergy.
It's a huge step, and it really highlights how we're thinking about the brain circuitry involved.
The amygdala, the hippocampus.
Exactly. The amygdala for the fear response, the hippocampus for context and memory storage, and the prefrontal cortex for regulation and control.
All working together, or sometimes against each other, in fear and its extinction.
Precisely. And ketamine seems to modulate the communication within this network, potentially shifting it towards successful extinction learning.
So when you look at all this research synthesized in the review, what's the single biggest thing that stands out to you?
For me, it's the clear potential, the promise that ketamine holds for actually enhancing the brain's own natural ability to unlearn fear.
Not just masking symptoms.
No, not just symptom relief, though that's important too, but potentially enabling a deeper, more fundamental shift in how the brain processes those traumatic memories, facilitating a more lasting change.
It's about enabling the brain's capacity to heal itself, in a way.
Beautifully put, yes.
Well, that brings us towards the end of our exploration today into ketamine and fear memory extinction. It's clear, isn't it, that while this is largely preclinical work still,
Mm-hmm.
it offers some really powerful clues about how we might, one day, genuinely help the brain relearn its responses to past trauma, moving beyond just coping.
Absolutely. And understanding this process, fear extinction, and how ketamine might influence it at this basic level, it really does raise a profound question for us all, doesn't it?
Which is,
What does this truly suggest about our potential to move beyond simply managing trauma? Could we actually facilitate a genuine alleviation, allowing the brain to truly fundamentally unlearn these ingrained fear responses and help people reclaim that sense of safety?
that is definitely something to think about. Thank you, as always, for joining us on Talking Ketamine.
My pleasure. Until next time, keep learning, keep exploring, and stay curious.